We've made it to the last homework assignment of the term, dealing with centroids, so 6.6 in your book. Looks like there's 5 questions, so 4 required, 1 extra credit. First question here, this does not involve calculus at all. So this is the finite case that I illustrated in the first of the 2 videos from this section. You're asked to find x bar and y bar, and they give you 3 points and 3 different masses. This should be almost identical to the example that I did in that video, so hopefully that'll go pretty smoothly for people. Second question, now this one and the rest of them will be the continuous case, not the finite case. So you no longer have like 2 or 3 or 4 or something point masses. You instead have an entire region, and you're supposed to figure out the centroid of that region. And they give you the region in a pretty nice format here. The 2 y curves will kind of bound the area above and below. And then they just explicitly tell you the bounds of integration, so hopefully that'll make things go pretty well for you. It's worth pointing out that one of the curves is y equals 0, the x-axis here. So when you're in that case where it is bounded below by the x-axis, there's a simplified version of the formulas that you can use instead. So if you go to the second video, there's a big box with the formulas, and then below it says something like, if it's bounded below by the x-axis, you can use this easier version instead. So on this problem, you can use that easier version. Question 3, you cannot use that easier version because it is bounded below by 6x squared and above by x squared plus 4. If you can just see that, that's great. If you can't see that, if you don't know what these graphs look like, just pull out Desmos or some graphing program and get a look at what the bounded region is. And then they ask you for the centroid. You might be able to figure out the x-coordinate of the centroid just looking at the graph. There's some symmetry going on here that you might be able to exploit. I'd probably still calculate it and make sure you get the answer that you think it should be. But I think x bar is predictable, whereas I don't think y bar is predictable. So I'll leave that up to you if you actually want to calculate this or just figure this out from kind of looking at the graph. And then question 4, the last one that you have to do. I don't think that there's anything that you can predict on these answers for x bar or y bar. I think you just got to go through and calculate them. So they give you these 2 curves, the curve above and the curve below. And then they give you one of the bounds of integration, and they say that it touches the origin. So maybe you can use that statement to figure out the other bound of integration. And again, on this one, we're not bounded below by the x-axis. So what that means is you'll have to use the full version of the formulas, the ones that are in the box in that second video. And then question 5, you can try it if you want or you can skip it. It is definitely not something you need to be able to do for this class, but it's related to this topic and I thought it was kind of interesting. So if you want to figure it out, you can. What's going on here is they kind of tell you the answer. They tell you the center of mass. They're giving you the centroid. The x-coordinate is 0 and the y-coordinate is 10. And they're saying you got these 2 different curves. One of them is f of x equals x squared. So maybe you can picture your standard parabola. And the other one is a constant. G of x equals just some number c. So you're thinking it's a horizontal line, but you don't know the height of that horizontal line. And what you're supposed to do is figure out what must the height of that horizontal line have been if the center of mass is at 0, 10. And my hint to you here is, because of the symmetry that we'll have with the standard parabola and any horizontal line, the x-coordinate of the center of mass has to be equal to 0. So this won't really provide you with any information. In order to answer this question, you will need to use the fact that the y-coordinate of the center of mass is 10. So maybe you can take the formula that gives you the y-coordinate of the center of mass, and then you could set that equal to 10, and maybe inside your formula you'll have a c floating around, and maybe you'll have to do some calculus with the c floating around in there, and maybe you'll be able to finally solve and figure out what c is equal to. And if you can get there, great. Be really proud of yourself. This is an especially hard extra credit question, and if you can't, definitely don't lose any sleep over it. Not a big deal. Just something you can try if you feel like it.